Today's topic is IBM Security Guardium Key Life Cycle Management, also known as GLKM. We have today with us Mahesh, and second speaker is Sushant.
Let me take you through the agenda now. We will go over some of the basic concepts around data security and encryption. What do customers expect when it comes to encryption and key management solution? What is it that we offer from IBM as part of the security Guardium Key Lifecycle Manager offering? What are some of the supported devices that we work with? There are plethora of storages and non-storages that we will just touch upon. And finally, an example of 359 to tape drive, how the data encryption works, and then summarize about the benefits and why you should use Key Lifecycle Manager and the solution from IBM. Okay, so here's the slide on what data security when it comes to the CI triad, confidentiality, integrity, and availability. Confidentiality is often associated with secrecy and use of encryption. Confidentiality in this context means data is available to only authorized parties. When it comes to integrity, it refers to the data not being tampered or degraded when it is submitted or transferred over the wire. And it is certainly not allowed to be modified by unauthorized people. That's what integrity translates to. When it comes to availability, that means the data has to be available at the right time to the right set of people when it is requested. So for an example, when an OTP is requested, if the OTP does not reach you on time for you to key it back on the prompt, then the availability is in question. So that's an example of an availability. So let's talk about what encryption is. Encryption is used to actually hide the data, or it is used to translate the plain text or the data that is visible to a normal eye into a ciphertext that is unreadable or encrypted. And this is done by using encryption keys. The encryption keys are used to encrypt the data, the plain text, and it gets converted to ciphertext. This ciphertext is either stored in storages or it could be actually then transferred over wire to an entity who will also be given access to the keys such that this person can actually decrypt the data and use it for their own purpose. So that's what encryption essentially translates to. There are two ways that you could encrypt. One is symmetric encryption, and this is normally used for encrypting data that is at rest, and it is done by using the same key which is used to encrypt. The same key is used for decryption. Asymmetric encryption or public cryptography is commonly used for transferring data over wire, and it has key pair, public-private key pairs, which are used for purpose of encryption and decryption. So let's talk about why you should encrypt data from security standpoint. Of course, the very basic is keeping the data safe and hidden from people who are not authorized to access it. That is why you would want to encrypt the data. You would also want to encrypt it such that just in case if it is stolen, the stolen data when it is in encrypted format is not accessible or not readable to the people unless they have encryption keys. Sometimes your data may be, at risk of getting stolen when the data is the disk or storage is sent for repair, or it could be stolen. So in either of these cases, it is at risk if it is not encrypted. So that's one of the big reasons why you would want to encrypt the data. The second reason is to actually comply. So for the same reason as maintaining confidentiality, a lot of regulatory standards and governance actually expect you to encrypt the data. For example, the PCI, the card industry actually expect that the data related to customers is actually encrypted and not uh, given access to any unauthorized user. Similarly, HIPAA, NERC, GDPR, all these standards have strict regulations when it comes to encrypting the data. And finally, one side effect, or I would say one of the advantages that you get as a result of encryption is that the data destruction or destroying the data becomes very easy. The data can be easily destroyed by just getting rid or destroying the keys. You do not really have to format the disk or destroy it physically to actually get rid of data. Just getting rid of keys actually will lead to data getting destroyed. This also brings the risk that if your data keys are lost, you would not have access to your data. So that's the other side of this sword. And it is very important as a result uh, to actually store your keys safely and use a mechanism such as key lifecycle manager to actually keep your keys safe. So this slide talks about the regulatory compliances uh, when it comes to uh, you know data breaches. If there is a data breach, uh, the regulatory authorities actually uh, come swooping down upon the violations, and actually there could be fines as high as you can see in case of GDPR, it is 20 million euros or 4% of the annual turnover of that particular company. And as a result, it can cause a serious damage not only to your reputation but also financial losses when it comes to non-compliances. So, just referring to the slide from the previous section, you would want to encrypt the data, and that is for two reasons. One is, of course, to maintain the confidentiality, and other is to actually comply with the regulatory standards. Now, data actually has different phases. Actually is, it can actually be in different stages. Data, when it is stored on disks or storage media, it is data at rest and it needs to be encrypted. And normally we use self-encrypting devices. The disks, the tapes are normally they normally encrypt the data using hardware accelerators, and they work with an external key manager to actually get the keys that are used to encrypt this data at rest. Data in use is the data that is being used by the applications, and applications normally use their own mechanisms to encrypt the data when it is being served or when it is being used for editing. The common example of data in use being encrypted is tokenization, where you actually tokenize, let's say, the credit card information or your Aadhaar information is tokenized when it is being used for the purpose of verification or validation. And then the data in motion, we use SSL, TLS, or HTTPS protocols to actually protect the data that is in motion. And data in motion normally uses asymmetric or public cryptography to actually encrypt the data. So we talked about encryption in different phases of data. And as you can see in the slide, data encryption is pervasive. So encryption happens at all layers. You encrypt your data when it is on a disk using symmetric encryption, and that's the lowermost, part of the pyramid that you're seeing. And it is basically the most fundamental or basic encryption technique that's used to encrypt the data that is lying in the storage. That is the minimum that one should do to actually keep the data safe from getting stolen or breached. The next level is the file system level encryption, where you have a little more granular protection against loss. And you could actually encrypt one particular file, or it could be an entire file system that you could be encrypting. As we go up, you have databases and table spaces, which actually could be used to, the data at that level is encrypted at the database level, or it could be also at a row level or a column level where you encrypt the data inside the databases. And then finally, you have the most complex and the granular level of encryption at the application level. And it is only the users who have access to the applications are actually granted access through the keys to the encrypted data at that level. So you can see that there are multiple layers of encryption, and sometimes it could be possible that your data is encrypted and decrypted multiple times in all these layers as you navigate through them to access the data. Okay, so now let's talk a bit about the different phases of data security lifecycle. What normally you see is the data in an enterprise needs to be discovered. So you need to know, have visibility to the entire data that is present in your IT environment. And the data could be in your on your on-prem data, or it could be on the cloud. And it is essential that you discover all this data, be aware of it, and classify it such that you can actually be able to decide what is the level of security that you need to offer to a particular set of data. The next phase is to encrypt the data, and that is where we have Guardium data encryption and key lifecycle manager, and that's the session we have today. We will talk about that a little more in course of time. Monitor, analyze, and respond are primarily for keeping an eye on the data, who is accessing it, why they are accessing it, and analyzing if there is a problem uh, in terms of access that is given to the data. And if there is a problem, then respond or react to it such that you actually uh, uh, apply the controls like revoking a particular user ID, or limiting the access, or making a user to have only read-only access, for example. So these phases of controlling, monitoring, analyzing, and controlling is can be achieved through uh, Guardium data protection and Guardium Insights products that actually help you to monitor, analyze, and respond to the threats that may be coming on your data, or vulnerability that exists on your data. So that's about the data security lifecycle.